Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0A94 indicates a performance problem with the DC-DC converter in the 2023 Honda CR-V. This converter is crucial for effectively converting high voltage from the hybrid battery to the lower voltage required by various electrical systems in the vehicle. If the powertrain control module, PCM, detects a malfunction in the DC-DC converter's operation, it will log this specific code as an indication of the issue. The DC-DC converter is typically located underneath the vehicle near the hybrid battery system. Diagnosing this error requires understanding the interplay between the converter and the PCM, as well as any other circuitry connected to them. Additionally, any abnormalities in this region can lead to warnings and further complications if left unaddressed. Understanding this error is essential for maintaining the vehicle's electrical efficiency. The error code P0A94 reveals a performance problem specifically associated with the DC-DC converter. The main role of this converter is to adjust the high voltage output from the hybrid battery to the lower voltages needed to power various electrical systems within the Honda CR-V. When the PCM, or powertrain control module, receives failure signals regarding the DC-DC converter, it logs this trouble code as evidence of an issue. The PCM acts as the brain of the vehicle's circuitry, ensuring optimal operation of all electrical components. If it senses any abnormalities in the DC-DC converter's performance, it will trigger this specific DTC. Therefore, diagnosing the issue requires checking the functionality of the DC-DC converter and its associated circuits. There are several potential causes for the P0A94 code. The first possible cause is a faulty DC-DC converter itself, which might not be functioning to convert voltages correctly. Another significant risk could stem from issues within the electrical circuits connected to the converter. Problems such as shorted wires or open circuits in the power supply lines can hinder the performance of the DC-DC converter. Additionally, the issue might also be attributed to a malfunctioning powertrain control module, PCM, which could result in improper error reporting. It is vital to systematically evaluate each of these components during the troubleshooting process to identify the root cause of the DTC. The symptoms associated with the P0A94 trouble code may include various electrical system malfunctions within the Honda CR-V. Drivers may notice dashboard warning lights activated, indicating potential issues that need attention. These warning signs often suggest that the DC-DC converter isn't adequately performing its role in maintaining electrical efficiency. Drivers may also experience reduced efficiency in the hybrid system due to improper voltage conversion, impacting overall vehicle performance. Potentially, these symptoms could lead to further complications if the issue is not addressed promptly. It is advisable for owners to stay vigilant for these signs to ensure the safe operation of their vehicle. The first step in troubleshooting the P0A94 code involves conducting a test drive of the Honda CR-V. This test drive helps establish whether the issue manifests while the vehicle is in motion or only under specific circumstances. It is crucial to follow up the drive by stopping the engine using the auto idle stop feature. This action will allow mechanics to observe any immediate responses from the vehicle's electrical systems after the engine shuts down. Capturing these immediate conditions can guide further diagnostic steps and confirm if the DC-DC converter performance problem is ongoing. In this step, the focus shifts towards verifying the integrity of the DC_STS wire in the Honda CR-V. This wire plays a critical role in signaling the operational status of the DC-DC converter to the powertrain control module, PCM. Conduct a careful inspection to determine whether the wire is shorted or has any open circuits. A thorough examination involves checking the wire connections and measuring resistance with a multimeter, ensuring that there is adequate continuity. Any abnormalities found during this inspection may indicate issues that affect the proper functioning of the DC-DC converter and should be addressed immediately. The third troubleshooting step involves a detailed inspection of the DC-DC converter itself and its output circuit. Mechanics should ensure that the DC-DC converter is properly connected and performing its function. This involves examining the output terminals for any signs of damage or short circuits and checking that the voltage levels are within expected ranges. Proper measurements can help identify if the converter is supplying adequate voltage to its intended systems. Any irregularities at this point could confirm that the converter has degraded and may require replacement to restore full functionality in the Honda CR-V. During this step, attention should be directed towards inspecting all connections related to the Powertrain Control Module, PCM. The PCM acts as the brain of the vehicle's electronic systems, and any issues here can cause the DTC to trigger. Examine the PCM for any physical damages, corrosion, or disconnections in the wiring harness attached to it. This includes verifying that all connections are secure and free from contaminants. Ensuring the reliability of these connections is crucial for maintaining optimal communication with the DC-DC converter. In the final step, it is essential to inspect other related components linked to the DC-DC converter and PCM. This requirement stems from the fact that a malfunction in one component could be affecting the performance of others. Conduct system tests to verify the function of other connected components, which may include sensors or additional wiring paths. By confirming that these parts are operational, you will rule out other potential causes that could be triggering the DTC. If everything appears normal, a known good DC-DC converter should be installed for testing. After completing all inspections and necessary repairs, it is imperative to verify the effectiveness of the repairs by retesting the Honda CR-V. This includes taking the vehicle for a test drive under conditions similar to those during the initial DTC discovery. Following the drive, clear any stored DTCs to ensure they do not interfere with future diagnoses. Monitor the vehicle for any recurrence of the P0A94 code or additional issues. This step is crucial for ensuring that all repairs have effectively resolved the problem and the DC-DC converter is now functioning correctly. Preventive maintenance is crucial in avoiding future occurrences of error code P0A94. Regular inspections of the electrical circuits associated with the DC-DC converter can help identify potential issues before they escalate. Keeping an eye on the performance of the DC-DC converter ensures that it operates within specified parameters and can effectively assist in maintaining electrical efficiencies. Recommendations also include checking connections for corrosion or wear and tear, which might compromise performance. Scheduled maintenance can significantly reduce the likelihood of unexpected performance issues in the DC-DC converter, keeping your hybrid Honda CR-V operating smoothly. In conclusion, understanding DTC P0A94 is vital for maintaining the optimal functioning of the Honda CR-V's electrical systems. This code specifically indicates performance problems with the DC-DC converter, which plays a significant role in converting high voltage to usable low voltage for various vehicle systems. A methodical approach to troubleshooting, including detailed inspections and component evaluations, is essential in diagnosing and resolving the issues associated with the code. Timely and effective repairs not only enhance the performance of the vehicle, but also ensure the longevity of the electrical systems. Adopting preventive maintenance practices can further minimize the risks of future abnormalities and performance issues. Please like and subscribe to the channel. See you